Welcome to Easy Maths. In this video, we will be simplifying algebraic expressions by multiplying and dividing. Now remember, expressions can be simplified by collecting like terms, which means we're adding and subtracting algebraic expressions. I've done a video on collecting like terms, which you can always go back to. Now we're focusing on multiplying and dividing expressions. So let's look at these examples. Now, if we start by separating our coefficients, 2 and 5. So this means 2 multiplied by 5, and then put our letters together. Multiplied by P, multiplied by P. Now this is the same thing as the original. All I did was separate my coefficients and my letters, my variables. So 2 times 5 is 10, and P multiplied by P is P squared. Now in the second one, we can do the same thing. Separate our coefficients, so that 7 multiplied by 5, put our variables together, multiplied by x squared, multiplied by x, multiplied by y. So again, all I did was rewrite. Now 7 times 5 is 35, and if we're multiplying same base, then we add our powers. Now remember, the power for this x is 1. So x squared plus 1, and then we're multiplying it by y. So let's write this. So that's 35 multiplied by x to the third power times y. Now in this one, we're dividing. So separate our coefficients would give us 16 divided by 2. And we could write x squared to be x multiplied by x all over x. Now again, all we did was rewrite our expression. 2 into itself is 1, 2 into 16 is 8, x into itself is 1, and x into itself is 1. So now we have 8x. Another way we could do this division is using the division law of indices. So if we're dividing same base, then we subtract our powers. So let's go. 16 divided by 2, and then this would be x squared minus 1. Because remember, the power here is 1. So 16 divided by 2 is 8 times x, 2 to the power of 2 minus 1, which is 1. So our answer is still 8x. Now pause the video, have a go at these, and then we do them together. Welcome back. Now in the first one, r is being multiplied by itself 3 times, so that would be r to the third power. In the next one, we could separate our coefficients. So in this case, we only have a constant. So 2 multiplied by 3, which is 6 times m. Again, 5 multiplied by 6. If you want, we could separate. So 5 multiplied by 6, and then multiplied by our variables, x multiplied by y. So 6 times 5 is 30 times x times y. In this one, again, let's separate our coefficients. So this would be 6 multiplied by 2, and then let's put all our p's together. Multiplied by p squared, multiplied by p q. Let's go to our q's. Multiplied by q. We know that the power of this q is 1. Multiplied by q squared. So all we've done is rewrite our original expression. 6 times 2 is 12. And when we're multiplying same base, we add our powers. P to the 2 plus 3, and q to the 1 plus 2. Now let's simplify. So this is 12 p to the 2 plus 3, which is 5, times q to the 1 plus 2, which is 3. And then for this one, we're dividing. So 12 times a to the 5th power times b to the 3rd power over or divided by 3 times a squared times b squared. Now 3 goes into 12 4 times. 3 goes into itself once. Now remember, if we're dividing same base, we subtract the powers. So this would be 4 times a to the 5 minus 2 times b to the 3 minus 2. So we're left with 4 times a to the 3rd power times b to the 1st power, or simply times b. Now, if you don't remember the division law of indices, please go watch the law of indices for division rule. Now, another way we could have done this division is by expanding. Let's see what that looks like. So that would be 12 multiplied by a times itself 5 times, multiplied by b times itself 3 times. And that is being divided by 3 times by a by itself twice and b by itself twice. So we could cancel or divide our a's, and we could divide our b's, cancel 2 of our b's. And then 3 goes into itself 1, 3 goes into 12 4 times. Now we're left with 4 times a by itself 3 times. 1, 2, 3. The powers are all 1, and times b. Now this method of expanding can be handy if we have small powers, but if we have large powers, then this will be quite time consuming, and so it would be better if you're familiar with the division law of indices. Well done.